Okay, sure. So let's get started. So one more data type we'll see before we actually get into hands-on programming. It is called as data frames. Okay, data frame. So data frame is like table representation in R. In Excel, we have the table, right? In Excel, we have columns and rows. Okay, so similar kind of structure we have in R, and that's called data frame. So it is okay. So I'll give you an example. Let's create a I'll say player stats. Let's create a variable called player stats, and here I'm going to assign some value. Okay, so so what is a table? Table has multiple rows and columns, correct? Each row represents one specific or one related information. Column represents same type of information, correct? So I'm going to create a function. See, in R, every variable, okay, is created with a function, right? We used C to create a vector. We use list to create list, arrays to create arrays, matrices to create matrices, um, the last one vector to create vector, right? So we use something called as data dot frame. Okay, it's data dot frame, not data frame. It's not a single word. It's data dot frame, and this is going to help us to create a table. Okay, so I'm going to add the column header first. Okay, so let's say I use player stat, right? So let's use something called as say serial number. Serial number, right? So this is a column header, and this will be a vector. Okay, because a column contains same type of data, right? So a column will have same type of data type. Okay, so that's why we create a vector here. Okay, inside data frame we are creating a vector. Yeah, right? So let's say we'll have 3 records just to just to demonstrate. Okay, so serial number, and then next we'll add, let's say, name, player name we call it. Okay, player name, and player name again will be vector. Let's say I add names like Sachin, okay, Rahul, let's say Rohit, let's say. Okay, and I'm going to add one more column called runs, let's say. Okay, and here I'm going to add some runs, say 12,000, 14,000, and let's say 15,000. Okay, and now I'm going to print it on the screen. So print player stats. Okay, now we'll run this. Okay, so you see this? It has created, okay, this data here, right? Okay, now what I'll do is, instead of this one, okay, let's give equal to. Okay, equal to, equal to. So see, there's a difference here. The moment we say equal to, so this became the header as well. See the difference? Did you see the difference here?
Yeah.
Okay, minor difference, but yes, sometimes we need to know when to use equal to. Most of the time, we'll use that arrow itself, less than hyphen. Okay. Okay. So these are the different data types. Okay. Now we'll move ahead. We'll talk about how to create a variable name. No, like player stats a variable name, right? Serial number is a variable name, in fact, right? So there are some rules which we need to follow. The first rule says that it has, okay, so it can contain, okay, so I'm going to put a variable names. Okay, so rules, first rule is that it can have characters, right? Numbers, so characters A to Z, capital and small case. Then you have numbers 0 to 9. Along with it, it can have dot and underscore. These are the only two special character which is allowed to put it in a variable name. Dot, for example, here we gave DataFrame dot. Okay, so of course this is a function, but yeah, you can use dot and you can use underscore. These are the only two special character which is allowed. So if I declare a variable name as, let's say, var percentage equal to 5, this is wrong. Okay, unexpected. Okay, but I can give a dot, I can give, okay, I can give underscore. All these are valid. Okay, underscore and dot are valid. You can't give space, right? You can't give space, percentage. Other than dot and underscore, you cannot give any other characters. Okay, one. Second thing is, okay, second rule says it should, okay, begin with a dot. Okay, okay, so remember here, the first character cannot be a number. Okay, so instead of saying should, let me write first character cannot be a number. So I cannot say one var. Okay, it has to begin with character. I can say var1, this is fine, but one var is not fine. Okay, it's invalid. Okay, you can start with dot. A variable name can begin with dot, but when you begin with dot, then you cannot write a number. It has to have a character, and of course after that you can write a number. So this is valid. Okay, and underscore is also not allowed. Okay, so a variable name should begin with a character or a dot. Okay, if it is a character, then it doesn't matter what comes next, but if it is a dot, then the next character has to be a character. Okay, underscore and numbers should not be in the first place. It can be anywhere in the variable name, but not at the first place. Okay, great. So we have already seen how to assign, right? We have seen three types of assignment. Can you tell me what are the three ways to assign a values to a variable?
Like with the characters.
But how do we write equal to sign in R?
Oh, like the arrow.
Well, it is like equal to, right? So how do you assign value to a variable? Using equal to and using less than hyphen or hyphen greater than, right? Hyphen greater than means the value is on the left side and the variable is on the right side. So value will go from left to right. Or you can have, okay, so what I meant is you can have this one equal to, or you can have hyphen greater than. In this case, value is moving from, value is on the left side. Okay, the constant or the value that needs to be assigned is on the left side and the variable is on the right side. Or you can have, okay, that means value is coming in from right to left, right? So less than hyphen, right? So indicates that variable is on the left side and value from right is coming towards left. Okay, that's how we remember. How do we find what is the type of what is type of a variable we discussed yesterday? how do we find what type of so let's say I've assigned var 55, right? I need to know what kind of value var has.
You print class of that variable.
Class of that, exactly. So class is a function.
I did the DataFrames thing, but it didn't work for me.
Okay, so it didn't. Okay, so I told you, right? It's don't practice, just watch me, okay? Because if you practice with me, probably you'll miss some other thing. But let's get it.
Oh, I
Okay.
thought I was supposed to do it at the same time.
No, don't do it at the same time, because when I'm doing, just watch, okay? And after that you can practice, and if you have problem in the next class, we can fix it. But since you got an error, let's fix it. So are you getting an error as such?
No, see, it's printing like everything above the data frame, but it isn't printing the actual data frame.
Everything above. So did you write print statement?
Yeah, I did.
Okay, so can you share your screen? Let me make you the host. I've made you the host. Can you share your screen?
So I printed like all of this, but not the actual data frame.
Yeah, because you have not run it. The print 49, you have not run it. Again, select and run. Click on run.
Oh.
See, it has printed now, right?
Okay, I don't know. I had to select.
Yeah, so I'll tell you. So I have not spoken about it. We'll speak about it now. Okay.
Okay.
So there, yeah. Can you make me host now? So there are multiple ways using which you can run, and it's property of RStudio. Okay, it's a property of RStudio. There are multiple ways you can run it. Most commonly is, with practice, I click on just run, because mostly you'll be making one line of code and you'll run it. Or if you want to run, okay, so see this option that you see here, run. This is used to execute the selected row. Okay, so Shivam is here. So yeah. So okay, so this option run. Okay, so if you click here, you see the comment there, what it says, run the current line or selection. Okay, so if I click, it will run the current line where my cursor is at, or the selection. So if I select all of these and I run it, it's going to run everything one by one. Okay, or I'll just point a cursor here and I hit run. Okay, so yeah,
I did that, but I'm still getting an error in the data frames.
What's the error?
It's saying that object player stats is not found.
Is not allowed.
Not found.
Not found. So probably you have not run the previous part. You must have run just the print, and you have not run it. So it is not able to find this variable. So put your cursor here and click on run, or as Keshav did, you select everything and you run it.
It still didn't work.
Okay, so let's share your screen. I'm going to make you the host now. Yeah, you should be able to share your screen now. Player stats. It should work. Click. Okay, see them. You have an error here. So that's why sometimes when you are new, better select just one at a time. You click on 52, you put your cursor on 52, line 52, yeah, and click on run. You can see. So this part is not executing, because of which it is not executed. So the variable is not yet created. Variable name is not yet created. So you have line of 55, you see that you have extra comma. Okay, comma we give only when you have more columns to add. The last column should not have comma. Okay, comma, when you put comma, it means that you're expecting something more after that. Right? Now you run 51. 51 is not, yeah, 51 or 52 rather, 52, right? Okay, I think it has run, and now you run next line and it will work without any problem, right? Yeah.
Okay, thank you.
Yeah, sure. You can make me the host now. Yeah. Okay. Yes. Okay, so that's the rule about for declaring a variable name. Okay, so as much as possible, just stay with me when I'm coding, so that you see what I'm doing and you can ask any questions. And later, you can practice, and if you have any problem, you can come back to me next day. But that's okay. 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 So we're talking about how to find the type of a variable, right? So using class, of course, yes, that's how you do it. Class of a variable will give the type of the data it has. Okay, not the value but the type of data. The next thing which I want to talk about was, yes, see, we've been using print statement, right? And it's case sensitive, so all small letters. So print, and we say hello, right? That's what we've been doing, right? Printing variables and things like that. Now let's say if I need to print more than two things, okay, now let's say I want to print, so print hello, and let's say I give name equal to, let's say, Keshav. Okay, and I want to say print hello comma name, let's say. Now here, okay, this is the fixed content and this is a variable name. So when you execute it, when we put it as a quotation, it is going to print as it is. Okay, if I give junk, it will print junk. Okay, it is not going to evaluate. But when you give a variable name, so variable name is replaced with its value. Okay, so for example, if I say print name, and when I run it, just like printing any variable name, it will print. Okay, the object name is not found because I have not run line 119. So I run line 119, variable name is created, and print name Keshav is printed, right? I want to print these two values together, hello and name together. Okay, so print does not support that. Okay, print can only take one value, unlike your other program, Python, Java, or C++, where you could give multiple variables or values to the print. Okay, whether it's a print line or C out or print ln, right? But R does not accept more than one argument. Okay, and we'll talk about what is argument. We discussed briefly about arguments yesterday, and when we talk about functions, we will talk about it. But it does not take more than one argument. Okay, so for that we have something called as cat. Cat is a function which will again print it on the screen, and here you can give multiple values with multiple arguments. Okay, so I copy it and I put it here, and now I run it. You see, hello Keshav is printed. Okay, that's one thing you'll see. Cat is going to print it like this. And if you see, the print also prints the quotation, but cat doesn't print the quotation. So that's one more difference. So that's why we mostly use cat to print, not print to print. Okay, so if you are if you are displaying some output, some content on the screen, you don't want to see this quotation. Okay, it doesn't look good, right? So that's why cat, okay, and also print has limitations. Cat, that's why cat is preferred way to print a content on the screen in R. Okay, and mostly we'll be using cat from now onwards. Okay, so yes, let's look at a couple of more important commands before we actually start programming. Okay, we are still trying to learn about R. Okay, we haven't yet started doing any program so far. So we have understood what data types are, how to find data types, how to print on the screen, right? Now we have a function called ls, and now ls is also Unix or Linux command. You can use it here in R. Okay, so if I say print ls is a function, and when I run it, it has displayed all the variable names which are there in my environment. My environment has all these values: a, b, calc function, condition, country list, etc. Okay, and you can display all the variables using ls function. Ls function will display all the variables which are stored in your environment. Unlike any other programming languages, when you close the editor, when you close the program, if you have not saved it, the things will get, variables will get deleted. You can, but in R, and R Studio maintains that list. Okay, so okay, so so this, so this is very useful. Let's say you are reading a very big data, right? And I told you, right, R is mostly used for statistical purpose. So let's say if you have a very big data, heavy data, which has probably 10,000 rows or million rows. Okay, when you read it, of course it will take time to read the content to R. So you read it, and now you're working on it, right? In other languages, what you'll have to do is you have to read it again and again and again, right? You do something, and let's say you're not happy with the output, you go and make some changes in the program, again you run it, again it has to read from the previous session the values. So execution can delay here. Okay, let's say if I have done line number 24 and till 23, 22, I'm fine. Okay, there's no problem. Okay, but 2024 is what I'm trying to change. So I don't have to run everything from 22, right? Okay, if I'm using a variable, it will be picked from the environment. So that's the advantage. Okay, when you're handling very large data set, if you have to read it again and again, it is very intense in terms of your computer resources, in terms of time. To avoid that, you have this option in environment variable where the values are, yes, if value changes, and if you don't run it, of course it will have the old value, right? So so you can run it again, and so that data is refreshed, you have the latest value. You don't have to rerun previous lines of code again and again. Okay, if I'm stuck with line number 24, if I'm not happy with the output, if I have to make more changes, I can continuously do 24. I don't have to worry about rerunning everything from 1 to 23. Okay, so ls is a function which will help us to get all list of all the variables that are there in the environment variable. Now you want to delete them, you want to remove them, of course we can do that. Okay, so how do you remove them? We have something called as rm. Okay, ls is to list, rm is to remove. Okay, so I need to remove, let's say calc function. Okay, I don't want this, so I'll select it, and here I'm going to say rm. Okay, and I'll give the variable name here. When I run it, okay, it is removed, and if you want to check it, you run the ls again. So see, the condition which was fourth has become third variable here, right? And when you see the output, you see these numbers. These numbers are indicating the number of values. So one indicate that this is one. In Python, in R, counting starts from 1. Okay, the first number is 1. In Python, the first number counting starts from 0. But in R, counting starts from 1. So this is your first variable A. So 1, 2, 3, 4, 5, 6, 7, 8. 8 is DF, and 9 is housing. So that's why it shows 9. So you don't have to count every variable. If I want to know how many variables are there here, I'll see 33. Okay, so this is 33. I don't have to count from 1 to 33. Of course, in this line, I have to count 33, 34, 35, 36. So there are 36 values in the environment variable. Did you get it? Any questions so far?
No.
No? Okay. Now let's say I want to delete all the variables here. Of course, we can do that. So I don't know if I told you yesterday or not. You can run multiple functions together. Like yesterday we did print and class, right? So class was inside print. So first the innermost function will be called and executed. So when you say print class, class is innermost, class will run, and the output will be then printed by the print command. So similarly, I want to first list down everything and then remove that list, right? So I can say rm remove what? I'll say list equal to ls. Now when I run it, okay, it has run successfully, and see, you can see it here, right? Environment is empty. All the previous variables are now deleted, right? So when you want to delete it, when you don't need it, you can do rm list, and all the variables will be deleted. If I want to see it, I can go and say print ls. See, character 0. There's no such value there. Any question so far?
No.
All good?
No. Yeah.
Perfect. Okay. So yeah, that's all about introduction part. Okay. Now slowly we will get down to our programming. Right?
Yeah.
Okay. Okay. So we will get started with first basic programs, and slowly we will increase the complexity. Okay. So the first thing that we're going to talk about is the number of operators. Okay. Or what are different operations that can be performed, or you can perform, okay, on in R. And I told you yesterday that the operation that you perform is dependent on the data. Like for numbers, you can perform plus, minus, into, division, square root, remainder, etc., etc. Right? Square root, things like that. When it is text, character, you will be concatenating, getting subset, things like that, right? So there are different types of operators. Okay. Okay, so this meeting will end in 10 minutes. When it ends, please join back again, right? Just like yesterday. Please join back. It shows 10 more minutes. Okay,
Yeah, okay.
perfect. Okay, so right, types of operators, right? Okay, so first thing is arithmetic operators. What does arithmetic means? Arithmetic. Sorry, ARI. What is arithmetic? Arithmetic. Yeah, that's the spelling. Okay, what is arithmetic, guys? Mathematics, right?
Yeah.
Right? So yes, mathematics. So we'll talk about different mathematics operations that we can use. So first thing is plus, or you add, right? So I can say where 1 equal to 5, where 2 equal to 10, and you print where 1 plus where 2, right? So run where 1, where 2, and print where, okay? So you get 15, right? We can also use vector. Okay, so I'll say where 1, I'll say C. Okay, and we add 3 variables here, right? So here too, I'm going to add vector 10, 20, 30. So see here, you look at how things change here in one variable. So I created var1, var2, so it created two variables here, isn't it? But now I'm going to replace the value of var1. So I'm not creating new variable. I'm replacing the existing variable's value. So see here, it got changed here, right? So it says number 1, 2, 3. That means it has three variables. Okay, 1, 2, 3, and values are 10, 15, 5, 10, and 15. Now when I run next line, var2 is also changed. And now when I run next line, output you get. So when you add two vectors, the first number will be added with the first number. Second member will be added to the second member, right? And if I create a different size of vector, let's say I add 4 here. Now when I run it, so see, longer object length is not a multiple of shorter object length, right? So if you're performing plus, minus, it has to be of same size, right? I go back and I delete 40. I run here, and when you print, okay, so you get, 5 plus 10, 10 plus 20, and 15 plus 30, right? Same logic applies for minus. So what I'm going to do, I'm going to copy, and here I'm going to say minus, and right. So you see here, 5 minus 10 is minus 5, and you have minus 5, minus 10, minus 15. So this is how minus. I'm sure you guys know this, but for the sake of understanding, we will do these things. Okay. So plus minus, same thing goes with into and division. Okay. So I don't think there's much to talk about into and division. It is same logic. So I'm going to copy these things, and I'm going to put here into. I'm going to put here into. I'm going to put here division. Division is slash, right? This is how you divide, correct? Okay. So now I'm going to select into and division, right? So you have 5 into 10, 50. 5 by 10, 0.5, correct? So, okay, this is how plus minus into division works, which I'm sure you know. Okay. Now let's look at other operators. They're still in arithmetic operators, right? So in arithmetic operators, you have something called as percentage. Okay. So what does percentage mean? So let's see this. And let me see if you guys can recognize what output it has given. So I'm going to replace this with percentage. Okay, 2%. Here 2, percentage twice. I did not get it. Yeah. So your percentage gives remainder. You know what is remainder? Yes, no?
Remainder is what's left over after you divide.
Yes, what is left over after you divide. So if I divide 15 by 10, remainder is 5. If I divide 21 by 7, remainder is 0. If I divide 35 by 4, remainder will be 3. If I divide 5 by 10, so then 0 times 0 and 5 is a remainder, right? That's how you got 5. So percentage is used to give the remainder of, by dividing first variable by second variable, and what was remainder is displayed in terms of percentage. So this is how you get remainder. The next one is percentage slash percentage, or percentage by percentage. So I'm going to say percentage by, okay, percentage by percentage by. What do you get? This gives, okay, quotient. This gives the quotient. So what is quotient?
It's like
So go ahead, go ahead.
when you're dividing like the answer.
How many times? Yes. Okay. So if you divide 5 by 10, then it is for 10 0 times, isn't it? You're not get, see,
So
division. Yes, go ahead.
for quotient, is it percentage slash percentage?
Yes, 3 characters.
Okay.
Okay, percentage slash percentage, 3 characters. So when you give only slash, only percent by, it will give you output in the decimal format. Okay, 0 point something, 1 point something, or 12 point something. That point something, okay, is the remainder, and the decimal part that you have 10 point or 12 point or 1 point, that is your quotient, right? So if you want only the quotient part, you say percentage slash percentage. If you want only the remainder part, you say percentage percentage. If you want both in decimal format, you divide and get with a simple by sign. Okay, so these are the operators, okay, or these are the arithmetic operators, okay, mathematical operators. Oh yes, there's one more to find the power. Okay, so let me copy this and show you that this is your caret sign, okay, or the cap, right? Not caret, we call it as cap. There's shift 6, the arrow going upward, right? This gives the power. Okay, so if I say 5, okay, 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 so we're talking about this caret sign, right, or the upward arrow sign. Okay, this is used to create exponent or the power, right? So if I, okay, so let's change the sign here first, and then we'll see the output. So if you replace this with the sign here, and okay, so let's have this 5 and we'll put it as 3. So power 5 to the power 3 is 125, right? So we can validate what we got is correct or not. I'll say 2, 3, and let's say I give 1. Or what I'll do is I'll give 0.5. 0.5 is 1 by 2, and I'll make this as 16 here. So now when you run it, what do we see here? So see, 5 to the power 3 is 125, correct? 5 square is 25, 10 to the power 3 is 1,000,000, and 16 to the power of 0.5, 1 by 2. So 2 is square, 1 by 2 is square root. 3 is cube, 1 by 3 is cube root. 4 is to the power 4, and 1 by 4 is 1, fourth root, right? So when you give 6, so that's how, using same command, okay, here when you have 16, right, and the power 0.5 is 1 by 2. So using same command, you can find power as well as root, right? Root is nothing but 1 by, right? So using this, you can find both power and root. Okay. So with that, we finish all our arithmetic operators. Now, I want you to write a program, okay, converting what do you call, like, into so let's say if I give 32 divided by 7, okay, so if I give 32 by 7, I want you to display it as 7 times 4 is 28, right? So 4 and then 28 minus 32 is what? 4. So it should be 4 by 7. This is what we call mixed, what do you call, I forgot the name, you must have done it in high school, right? So 32 by 7 can also
Yeah.
be written as 4 into 4 by 7, right?
Yeah.
Right? So I want you to write a program where you take variable A as 32 and B as 7, and I want you to give me this as output. Let's do it, and once you are done, you can send your code in the chat. I'll copy and run it here. Okay, let's do this. Pause recording. So take your time. So this is the input. Input is 32 and by 7, and output should be 4 into 4 by 7. What you see on the screen.
When I'm making a new project, it's asking for new directory, existing directory, or version control. Which one should I do?
No, do new file.
Yeah, that's better. Do the profile. Okay, so you have var 132 7. Okay, and quotient equal to this, fine. Okay, so this is good, but use cat to print. Okay.
Wait, what's cat?
Okay, so I'll tell you the problem here, right?
Well, for me, cat wasn't working. Like it wouldn't let me do multiple. It would just say unexpected value.
Yeah. So see, when you say print, right, it actually prints the value of it. But we don't want to do that, right? We want to print 32 by 7 as it is, right? So the first thing that I have to make here is, we'll say here cat, I want var1 to be printed as the value of it, right? So this is fine. After this, you put comma, and I want to put the slash as slash, not the divide slash. Okay. Now when you run it, so you say this, you get 32 by 7, right? Now, okay, so again, same thing happens here. So what I'll do here, okay, I want to put equal to, right? So I'll say comma space equal to. Okay. Now I need to print the remainder. So this is what I need, right? So I'm going to copy this here, or I'll just copy this whole sentence as you have done. I'm going to control X and do it here, and I'll put this rem. After rem, we need a blank space, so we'll give a blank space. Then we need the this part, right? Question part. So this I will do control X and put it here, and I'll say quote. right? And then division. So again, I'll use divide sign, and here I'll say var b. Okay. So now if you want, let's run it and see. Okay, see, this is what we wanted, isn't it? So cat is like print, okay, but in print you cannot give more than one value. Here you can give multiple values. So see, var1 is a variable name, so it will be replaced with its value. This we have given as a character with quotation. So when you give something in quotation, it will be printed as it is. Then again, value, variable value here equal to as it is. Rem value here space as it is. Code value here slash as it is, and variable b value here. Yes.
Yeah, that makes more sense.
Yeah.
Thank you.
Okay, great. So now I want to give you some assignment. Okay, so just give me a second. I'll pull up the slide. You can see my screen, right? So here you have three problems. Okay, so this is the statement, and the formula is d equal to r into t minus 16 into t square. Then this is the evaluate 3y minus 1 equal to 2 by 3 x square plus 2x minus 1. We have to find the value for y. Okay, when x equal to 5. So first you have to form the equation, then you replace, you give x equal to 5, and you need to get y value. Okay, and then this is the problem statement. So today I would, you both can try it separately. Okay, and let's see tomorrow how much can you get. If you have any problem, then tomorrow you both try together. Okay, and then if you don't get it, day after we will discuss, right? So what I'm going to do is I'm going to share this in the group.
Are these like two separate problems?
These are okay. So yeah, so with that we finish our arithmetic operators. We will just talk about relational operators. Okay, so relational operators is to check the relationship between two variables. Okay, so here you have greater than, less than, equal to, not equal to, right? Okay, then you have greater than, equal to, less than, equal to, right? These are called the relational operators. So the relational operators, okay, so okay, coming back to arithmetic operators, so arithmetic operators, okay, and this is true with any operators, right? Actually, the way we write in mathematics is that operator is in between two values, right? You have two values or two input on the both sides of operator. So for example, if you say plus, you have one value on the left of plus, other value on right of plus, right? So you have two values, and operator is in between, right? And then it returns a value, it gives us a value, right? So if I say 2 plus 5, it will perform addition of 2 plus 5, and the return value will be 7, right? So you have one output, mostly you have one output, right? And input can be any number of input. Okay, so for arithmetic operators, the inputs are also numbers, and output is also number, right? 2 plus 5 is 7, right? So input is 2 and 5 numbers, output is also number. In relational operators, what do you think is the output and what is the input? So I want to compare 5 and 7, which is greater. Okay, so it's like asking question, is 5 greater than 7, right? So input, you're getting numbers 5 and 7, and output is either true or false. That's it, right? So output is logical, right? So if I give var1 as say 4 and var2 as say 5, and I'm going to say print var1 greater than var. So var is 5, var1 is 4. 4 greater than 5. What do you think answer would be? So it's like saying, is var1 greater than var? Is it greater or not?
No.
No, right? So if I run it, you will get false. So input are numbers, right? 4 and 5, but output is a logical, right? Okay. So if I say 5 and 5, then what do you say? Is 5 greater than 5?
No.
No, right? So here also you will get false. Now if I put equal to here, is 5 greater than or equal to 5?
True.
True. Yeah. Okay. Similarly, you can have, so this is greater than, you can have less than. Is 5 less than equal to 5?
True.
True. Okay. What do you think output of this would be?
False.
Right. Okay. So less than, greater than, less than equal to, greater than equal to, very much like mathematics, right? Now, if you want to compare, is 5 equal to, I don't want to compare less than or greater, I want to check if it is equal to or not. So here what we do is we give double equal to. Okay. Single equal to is assignment. If I say var1 equal to 5, I'm assigning value 5 to var1. But when you do double equal to, it's like asking question, is var1 equal to var? What do you think the answer would be? What do you think the answer would be?
True.
Yes. Okay, 5 is equal to 5, right? So you get true. Okay, if I make this as 50, then of course answer would be false, right? And if you want to compare if value is not equal to, so we give this exclamation mark and equal to. Exclamation mark equal to is to check if the values are not equal to. So 50 is not equal to 5, so you get true, right? So less than, greater than, less than equal to, greater than equal to, not equal to. Single equal to is for assignment. Double equal to is to check the condition. Is it equal? It's like asking question. Is it equal? Answer would be either true or false. That's it. No third option. Similarly, not equal to is to check are the values not equal to. If they're not equal to, you get true. If they're equal to, you get false. Right? So these are called as relational operators. It checks the relationship between two values. Okay, you can do it for vector as well. We did it for numbers, but same thing holds true for vector as well. So for vector, you will get in answer for each of the values. Okay, so if you have 4 values, okay, 4 variables in vector 1 and 4 variables in vector 2, each of the variables will be compared and 4 answers will be displayed. Okay, so let's try for this not equal to itself. So let's say I declare var1 something like this: 50, 60, 70, 80. Right? Now 5, 60, 80. Okay, and let's say 80. Okay, so when I run it, okay, so you see it is comparing for each. 50 not equal to 5, true. 60 not equal to 6, no, false. 60 not equal to 60, false. 70 not equal to 80, true. 80 not equal to 80, false. So you get 4 answers. Right? So we will end it here for today. Any question before we wrap up, or all good so far?
All good.
Keshav, you good?
Yeah, I'm good.
Yes. So please do practice. An assignment I've already sent you on WhatsApp, and we'll meet tomorrow at the same time.
Thank you.
Thank you. Have a good day, guys. Take care. Bye.